Hello, welcome back. We are continue with chapter 4, chemical bonding, still in the subtopic 4.1, Lewis structure. In this video, we are focused on objective D, draw the Lewis structure, which may contain single, double, and also triple bonds. Then we also going to discuss about the exception to the octet rule. Okay, let's start to learn how to draw the Lewis structure for a covalent compound. Okay, so emphasize again, the step showing here is to draw the Lewis structure for the covalent compound. Let's start with the step number 1. We are going to count the total number of valence electron. So it is a reminder, try to remember the number of valence electron or the group number for the common elements that you frequent to meet or see in this topic. Okay, so we'll take the BeCl2 as an example. Boron is group 13, so have 3 valence electron. Chlorine have 7 valence electron. Here have 3 chlorine, so 7 times 3, 21. Then we total up equal to 24 electron. Okay, next one, how about if the molecule given is not neutral but with the ion, let's say negatively charged. As we all know, negatively charged means gain electron, so we will add the electron based on the charge. Okay, so look at second example here. Number of valence electron for phosphorus is 5, for the oxygen is 6. But here we have 4 oxygen, 6 times 4 equal to 24. Then the charge here is 3 negative, means that this PO4 going to gain 3 electron. So 5 plus 24, 29. 29 plus 3 total equal to 32. Then now, how about cation? So cation means that they are going to lose electron. So if lose electron, we are going to subtract the number of electron based on the positive charge. Again, one example, ammonia have 5 valence, nitrogen have 5 valence electron. Each hydrogen have 1 valence electron multiplied by 4 equal to 4. Negatively charged means lose 1 electron, so that's why here we have minus 1. So the total valence electron is equal to 8 electron. Continue with step number 2. We are going to pick the central atom. Okay, so the theory criteria to know that which one is the central atom is based on the electropositive. Okay, but I think because of in the previous chapter we learned about electronegativity, so the opposite side, the more electropositive atom will be the central atom. So that means if we relate with electronegativity, we will think that the least electronegative will become the central atom. So means that generally they are going at the left side of the periodic table. Okay, PT is periodic table. Okay, so the least electronegative is the central atom, while the most or the more electronegativity will become the terminal atom. So if you think that these two is quite complicated, or sometimes you may forget about the electronegativity of the element, then we have a quick check here. The first atom appear in the formula always will be the central atom. For example, BeCl2, first element is boron, so boron is the central atom. PO4 3 negative, phosphorus central atom. NH4 plus, nitrogen. IF3 iodine. COCl2 carbon. So all these first atom appear in the molecular formula will be the central atom. Okay, continue with step number 3. Draw the skeletal structure. So skeletal in Bahasa we call rangka. Okay, so that is why just now we need to know the central atom. Boron is the central atom. We place it in the center. Tengah-tengah. Phosphorus also center. Nitrogen center. Carbon center. So others elements Cl3, O4, H4, OCl2 are the terminal atom. So means that all these atom is going to bonded to the central atoms. Continue with step 4. Distribute electron. So distribute have the meaning of assign, assign, okay, the electron to the terminal atoms until octet 8 electron means, except for the hydrogen duplet means 2 electron. Okay, so previously in the step 1 we already calculate there are 24 valence electron for BeCl3, 32 valence electron, and this one have 8 valence electron. Okay, so now each bond here already have 2 electrons, so means that each terminal atom still need another 6 electrons, so 2, 4, 6. Okay, here also 2, 4, 6, 2, 4, 6. Okay, then now we are going to calculate, is it all the total 24 electrons are here? So for example, now here we can see there is 3 terminal atoms. So each terminal atom have 8 electrons. So you have 3 terminal atoms times 8 equal to 24. So total valence electron is 24. In your structure here, already showing 24 valence electron. So means that there is no extra valence electron. Okay, same case happened to the PO43 negative. We have 4 terminal atom here, and then each terminal atom going to achieve octet. So 4 times 8 equal to 32. So again, PO43 negative also doesn't have extra valence electron. Okay, but this time we have 4 hydrogen, but we are not going to use 4 multiplied with 8. Okay, because just now we already mentioned hydrogen is always achieve duplet. So we are going to times 2. 4 times 2 equal to 8. So this one 8 valence electron minus. So also doesn't have any extra valence electron. Just in case, if you minus the electrons that showing here and then have extra electron, we are going to place the extra electron into the central atom. Now let's continue with tutorial question number 6. Draw the Lewis structure and then give the comment on any unusual features. Okay, we are not going to continue with the unusual feature first. We try to learn how to draw the Lewis structure. Okay, so as we know just now, step number 1, we have to calculate the total valence electron. Xenon have 8 valence electron. Fluorine have 7 valence electron, but altogether, based on formula, we have 4 fluorine. So 7 times 4, 28. Xenon 8 electron. Total up is 36 valence electron. So if you are still not familiar with the number of valence electron, then it is always better you have a periodic table with you. Okay, and then from time to time you will notice there are some very common element always will be used. Then you try to remember the number of valence electron. So as we know, we are going to choose the least electronegative atom as the central atom. So for information, in chapter 3 periodic table, we already know fluorine is one of the most electronegative element. So means that xenon is less electronegative. So I will put xenon as the central atom and then bonded with 4 fluorine. Okay, at the same time, I already draw out the skeletal structure. So then now, step number 4, going to assign the electron to the fluorine in this case until octet. So means that each fluorine still need another 6 electrons. So altogether here we have 4 terminal atom. Each terminal atom achieve octet. 4 times 3, 32. So I minus 32 over here. So now still have others. Another 4 valence electron are not shown in the structure here. So just now we mentioned if there is extra electron, we're going to place the extra electron at the central atom. So one pair is 2 electron. So then we continue with the second pair, so 4 electron. So minus 4. So now in this structure here, all together we have 36 electrons. So this is the Lewis structure for the SeF4. Okay, so we haven't continued with the part unusual features. After we draw all the Lewis structure in question number 6, then only I will discuss the unusual features with you. Question number 6.2, aluminium boride. Again, step number 1, total valence electron. Aluminium 3 valence electron. Bor mean 7 valence electron multiplied by 3, so 21 plus 3, altogether 24 valence electron. Again, first element is aluminium, so aluminium will become the central atom. Then step number 3, we are going to draw the skeletal structure. So each terminal atom, make sure it is octet, so add on another 6 electron or 3 lone pair electron. So each terminal atom octet, here have 3 terminal atom, 3 times 8 equal to 24 minus 24. In this case, there is no extra electron. So this is the Lewis structure for AlBr3. Continue with number 3 NO. Always again follow the step. Step 1, calculate the total valence electron. Nitrogen 5 valence electron, oxygen 6 valence electron, total 11 valence electron. So nitrogen is the central atom. Draw the structure, skeletal structure for NO. Oxygen is the terminal atom. Make sure it becomes octet. So based on here, we only have 1 terminal atom, minus 8, so equal to 3. So we will place 3 valence electron at the nitrogen. Okay, then in this case, you will notice that nitrogen is not achieved octet yet. So then now we are going to move 1 pair of electron from oxygen. So we minus 1 pair of electron. We move this electron to share with the nitrogen. So in this case, nitrogen already have 7 electrons surrounded it. Okay, how to get the 7 electron? 2 bonds, so 4 electron, 5, 6, 7. Okay, but then haven't achieved octet yet. In this case, possible for us to move another 1 pair electron and to form triple bond here. Okay, this is not possible because nitrogen is in period 2. So maximum electron that can be held by nitrogen is 8 electron. Okay, so means that 7 in this case is maximum already. So this is the Lewis structure for NO. Okay, next again, continue with question number 5. Step 1, phosphorus 5 valence electron, chlorine 7 valence electron, multiply with 5. So total will be 40 valence electron. Central atom is the phosphorus. Step 3, draw the skeletal structure. Phosphorus in the center. And then come with the chlorine. 5 chlorine. Each chlorine is going to achieve octet. Come with 3 lone pair. So we have 5 terminal atom. So each terminal atom achieve octet. So 8 times 5 equal to 40. So in this case, minus 40 valence electron. There is no extra electron. So this is the Lewis structure for BeCl5. Last question, BeCl2. So beryllium 2 valence electron, chlorine 7 times 2 equal to 14. So total up is 16 valence electron. First element beryllium. Beryllium will be the central atom bonded to 2 terminal atom. Which terminal atom going to 8 electron? So 8 times 2, 16 minus 16. So there is no extra electron. So this is the Lewis structure for BeCl2. Next is the ClF3. Still as usual, we need to find out the valence electron. So if you notice, chlorine already appears quite many times. So all of you suppose already know chlorine has 7 valence electron. Fluorine also same case have 7 valence electron, 21. So basically it's 7 times 4 equal to 28 valence electron. Central atom is the chlorine. So now we try to draw the skeletal structure, and then step 4, complete the terminal atom with 8 electrons. So in this case, if you look at here, we have a 3 terminal atom. 3 times 8 equal to 24 minus 24. So we still have extra 4 electrons. So there will be have 2 lone pair electron here. So we can put here 1 pair and then here 1 pair. So this is the Lewis structure for ClF3. Okay, if you notice just now, the 6th Lewis structure that you draw, there is none of them follow the octet rules. Okay, means that the central atom is either surrounded by less or more than 8 valence electron. So we consider that they are not obey octet rules. So there are 3 types of exception. The first one is known as odd electron molecule. So from the word odd electron, so we roughly get the idea the central atom has odd number electron. Okay, so odd number is dalam bahasa nombor ganjil. So can be 1, 3, 5, 7, 9. Okay, so mostly always refer is either is 7 or 9 electron surrounded at the central atom. Second type is incomplete octet. From the terms incomplete means that tak memenuhi ataupun tak cukup lah. So indirectly means that the center atom has less than 8 electron. Okay. While the last one, number 3, expanded. So from the word expand, mengembang daripada 8. So we know that the central atom may surrounded by more than 8 electron. Okay, so now we try to look at what kind of central atom, or what is the example of the central atom that are possible to show odd electron molecule. So mostly are from odd number group, which is group 15 and group 17. Okay, so when we look at here, the central atom is nitrogen. So in this case, we consider nitrogen have 2, 4, 5, 6, 7, surrounded by 7 electrons. So same case happen at here, central atom is the nitrogen, 2, 4, 6, 7 electron. Next one is the chlorine. So 2, 4, 6, 7, 7 electron. So all these are the example of the molecule that can known as odd electron molecule. So second type of exception, incomplete octet, just now we already say, has less than 8 electron at the central atom. So normally they will involve the element in group 2 and group 13, basically are in the period 2, okay, because they are not going to donate electron. but it shares electron. Okay, so beryllium, 2 electron, 4 electron. Aluminium, in this case 2, 4, 6, 6 electron. Boron in this case also 2, 4, 6, 6 electron. So we will notice the number of electrons surrounded by the central atom all are less than 8 electrons. So we consider it as incomplete octet. Last, as mentioned before, central atom, again and again emphasize, we only need to focus on central atom. Okay, always have more than 8 electrons. Normally it will involve element in period 3. Okay, so now we look at PCl5, phosphorus, 2, 4, 6, 8, 10, 10 electron. Sulfur in the central atom, 2, 4, 6, 8, 10, 12. Bromine also we will take over here, 2, 4, 6, 8, 10. So all these example, seeing here is have more than 8 electrons, and all these elements are elements in period 3. Okay, now we continue with the second part of the question, unusual features. So we know it is referred to the exceptional. We have 3 types of exceptional. Okay, then we focus on the central atom. Okay, so SEF4, the central atom is the xenon. So when we look at here, 2, 4, 6, 8, 10, 12. 12 electron. So this one, the type of exceptional is expanded octet. Second part of the question, aluminium bromide, central atom, again focus, 2, 4, 6, 6 electron. So this one, the type of exceptional is incomplete octet. In this question, nitrogen is the central atom, and this nitrogen have 2, 4, 6, 7. 7 electron surrounded by 7 electron. So that's why the unusual features is odd electron molecule. For this question, we are going to focus on phosphorus. So 2, 4, 6, 8, 10, 10 electron. So in this case, this molecule is showing expanded octet. Continue with second last molecule. So focus on beryllium. So 2, 4, 4 surrounded by 4 electrons. So this one is incomplete octet. Last question before we end this video. Central atom is chlorine. 2, 4, 6, 8, 10 surrounded by 10 electrons. And the type of exceptional is expanded octet. Thank you for watching this video. So this is the final answer for tutorial 4.1 question number 6. Thank you. See you again in next video.